So are you able to see the black screen?
Yes, sir.
Yes, sir.
Okay. So we are dealing with LU decomposition method. So we have system in the matrix form like Ax equal to some B. Okay. So our goal is we will decompose the coefficient matrix into L and U multiplied by x equal to you have B, and then what did we do? We assumed the upper triangular matrix multiplied by x equal to some G or some Z matrix or vector, whatever. So Ex equal to Z. So therefore, now you have Lz is equal to B. So now what is known here? Matrix L is known to you. B is already, we know this B. So this is known to us. Now we have to compute Z from this equality. So once we compute Z from this equality, now you plug in this Z here. Okay. So let's say this is my equation 1 and this is my 2. So you obtain Z from, so obtain Z from equation number 1 and plug into equation number 2. That's it. Now this is known to you. So once you know Z, you put this in Z. So this is known to you. And what about upper triangular matrix? Do you know this? Yes, you know this as well. Now we can compute this X. Agree? So this is what LU decomposition. So we can exercise LU decomposition using Gauss elimination method and also using Kraut's method. Okay. So in Gauss elimination method, what we do is we will take diagonal ones on the lower triangle. See, we take a lower triangular matrix, and for lower triangular matrix you have diagonal ones, and the remaining things we can find the multiplier factors, in obtaining upper triangular matrix. That means upper triangular matrix, as usual, we find using forward elimination technique. Okay, and that we know already. Now coming to this lower triangular matrix, in the process of making upper triangular matrix, we will find out certain multiplication factors. Okay, so those multiplicative factors we will make use in our lower triangular matrix, and deliberately what we do, the principal diagonal of lower triangular matrix we will treat as ones. Okay, what I'm saying is this. For example, we have one system, right? What is the system here? Anyone? We had one system already. We are using that system. System of equations. We have some system of equations, right? First one is what? 3x1
Minus
Minus
0.1.
0.1 x2.
Okay, minus 0.1 x2 minus 0.2 x3 equal to
7.885.
7.8. Okay, 7.85. Then you have 0.1 x1
Plus
plus
7x2
plus 7x2.
minus 0.3 x3
Okay, minus 0.3 x3 equal to
minus 19.3.
minus 19.3.
Yes, sir.
Okay, and then you have 0.3 x1
3x.
minus 0.2
0.2 x2.
0.2 x2 plus
10 x3.
10 x3 equal to
71.4, sir.
71.4. Okay, so once you have this, now I collect these coefficients here. So let me collect the coefficients, and you have 3, negative 0.1, and negative 0.2, 7, negative 0.3, so 0.3, negative 0.2, and positive 10. So my A matrix is this. This is my coefficient matrix A. Now you have to decompose this. Already we decomposed using Gauss elimination method, I think. I mean, what I want to say is we have to make our A multiplication of lower triangular matrix by upper triangular matrix. So what is U here? You know, right? Already we know how to find U. Yes or not? In the process of finding U, yeah. Now, first of all, you tell me what upper triangular matrix we have. Already found this, okay? Already found this, right? What is that you have?
So 3.
Hmm? Yeah, what is this not coming? Not living here, okay? Yeah. So what upper triangular matrix we have here? Can you tell me? You.
3
Okay, 3
minus 0.1 minus 0.2.
minus,
0.1
okay,
minus 0.2,
minus 0.2,
0,
0,
7.00333,
7.003,
triple three, sir.
okay, triple three,
Minus 0.2933,
okay, minus 0.29333,
and then 0,
00,
10.0120.
10.0120. Fine. So yeah, now we made this quantity 0, okay, below this pivot element 3, you made this quantity, the next quantity here, 0. How did you make it possible here? How did you make that 0? Yeah, that for elimination is okay, but what is the multiplier there? What is the multiplier factor in obtaining that 0? Yeah, very good. So we have to take this one, right? So we use this one, 0.1 by 3. Okay, because this multiplier, we multiplied with whom? The first row, okay? 3 like this. Then we subtracted the entire story from whom? Second row, 0.17, negative 0. This is what we have done. In achieving, I mean the second row, whatever, okay? Of course, the second row. So therefore, now what I'll do here is, what I'll do here. So this is my multiplier, 0.1 by 3. What is the value for 0.1 by 3? So 0.1 by 3 is equal to 0.333, so on, right? Okay. So now, yeah, now let me take the skeleton of lower triangular matrix. Upper triangular matrix is ready, we know. Now this lower triangular matrix turns out to be like this. You see, U, the size of U is what here? 3 by 3. Yes or not? And already we have the size of A is 3 by 3. Now what must be size of L? Again, same
3 by
3 by
3.
3. That means you see, matrix multiplication must be always conformable. Okay, conformable means what? This
Number of rows in
equal
first
to
matrix
this
should
one.
be equal to number of
Good,
columns in
correct.
second
So
matrix.
therefore, L must be. So let me take this way. Let me take L as lower triangular matrix, L11. So I have diagonals here, L22 and L33. So I have zeros all the way here, like this. Now, this is what? This is L21, and this is L31 and L32. So this is my lower triangular matrix. Again, the size of this matrix is 3 by 3. All right. Now, fortunately, what we have is this. Fortunately, the principal diagonal stuff, L11, L22, L33, we can treat them as ones. So we have ones on the principal diagonal. So we are fortunate in this case. So let me rewrite this stuff. Okay. So I have 1, 0, 0. And now L21 we need to find again 1, 0. So L31 need to find L32 also 1. Okay, so we have this skeleton of, for the lower triangular matrix. Now L21, this L21 can be replaced by what value? 0 point this one. Because you see, if you observe here, why so? Why we have to take L21 is equal to 0 point, it's not getting down, it's not shrinking down. Okay, this is the minimum, I think. You see this 0, you focus on this 0 here, and that 0 with whatever multiplier we achieved that 0, okay, that multiplier we have to replace here at L21. Are you getting this? So this 0 belongs to this, okay, L21 and 0 have some connection like that. So therefore I could say L21 is equal to 0.03333, so on like this. Agree? Agree?
Yes, sir.
Yeah.
Yes, sir.
Okay. Now coming to L31. L31 could be what here? See, L31 is in the place of this. See, you have like this is like U31, okay? So in place of U31, just compare L31 and U31 positions. Just compare like that. So these two positions, this is U31 and this guy is L31. So to make this U31 as 0, we used a multiplier, and that is what? 0.3 by 3. Agree? So we should take only multipliers as the lower triangular matrix elements, okay? So therefore, we should take 0.3 divided by 3. From the coefficient matrix, we have this, okay? So 0.3 by 3 is equal to what here? It's 0.1.
0.1.
That's it. You can take further this if you want, so on, whatever. So you have 0.1. Okay, so for God's sake, we obtain these two values. First one is, this one is 0.03333, so on. I can take some bar like this. And this one is what? 0.1. Now, how do we find L32? It's again same, simple. How did you make this as 0? What multiplier did we use? I'm sorry, I've made it up. Where I'm going, this is again getting stuck. What is this? This is a 5 variable K map. Okay. Okay, how did you make this element 0 in upper triangular matrix? U32. We used some multiplier for that. What is that? We used a certain multiplier to make U32 as 0. This one as 0. Which multiplier is that? So now what is important point here is that whatever astras you are using to make to prepare an upper triangular matrix, in making so, whatever multipliers we used, however we use that, and that we require now, we have to capture those multipliers, and those multipliers at proper places of lower triangular matrices you have to accommodate. So once you do that, you are done with your L matrix, okay? Because U matrix I know. Now anyone, L32 is what you are here?
Minus 0.27.
Yeah, excellent. L32 is equal to minus yes
0.2.
okay 0.2 divided by yes or not?
Yes, sir.
Okay, this is what this is what. Please don't do this one. Please don't, in this case, don't do this. Minus 0.2 by 7. No, it's not minus 0.2 by 7 because we have modified one, right? Because we have a modified row 2 and row 3. And from that modified row 2 and row 3, we need to obtain this multiplier. I mean, this multiplier. That is like minus 0.2 by 7, whatever. So what is the answer for this? Minus 0 point approximately minus 0.02713. Did you get like this?
Sir.
Yeah. So this is okay. And see, the same thing also we can do in MATLAB. We will do this. It's very simple. Decomposing any matrix in L and U form may be hectic for us, but for MATLAB it is, it's a straightforward stuff. Okay, now put together, that means you have to replace this guy by negative 0.02713. This is an approximate result, okay? So now A, coefficient matrix A is equal to L. This is almost a pakka question in examination here, okay? Maybe you'll get for, I don't know whether you have offline or online examination, but this is a very important topic for exams especially. Okay, I have a 3 by 3 matrix. So for lower triangular matrix, I'll take diagonal ones, and I have my stuff ready. So that is, this one is, let me use yellow for this, just to segregate from other elements, 0.03333, so on. I'll take so on like that. And this is what, 0.1, and this one is negative 0.02713. So what I'll do here is I'll remove, okay. Okay, so I have principal diagonal 1 here, and again I'll be having 1 here, okay? So I have remaining zeros, so 0, 0, and 0. Okay, so A is equal, L equal to this, and my U is same, my whatever matrix I have for U, my U is 3 minus 0.1 minus 0.2 0 7.0033 and minus 0.2933, and this is 0 0 and 10.0120. If you can also check it, just multiply these two matrices, again you will get your original coefficient matrix here. Okay, now we are ready with L and U matrices. Okay, so this is your L matrix and this one is your U matrix. Now what is our step 1? So we need to construct this relation, Lz is equal to B. Okay, so I'll take my L, let me take my L again. So my L matrix is 1 0. L matrix is, first I'll write in terms of columns. So I have here 0 1 negative 0 2 7 1 3 0 0 1. So I'm using this relation, that is, what I'm using is this. I have, from my derivations, I have this Lz is equal to B. So I'm equating something this way. So Lz, so L is this, and what is my Z? Yes, correct. So Z1, Z2, and Z3. Now, what is your B? Your B is your system constants, the right hand side column vector you have for the system. And what this guy is getting stuck. Yeah, so I have, this is my B,
7.8
7.85, negative
minus net
19.3, 71.4. I forgot again, what do we have here? 7 point,
85, sir.
okay,
Minus 19.3,
minus 19.3,
71.4, sir.
71.4. Thank you. So I have this. Now, you know, when you have lower triangular matrix, what do you do to find these unknowns? You have to make use of forward substitution, okay? We did not remember these methods, whatever. It's quite evident from the equation. You can do that, okay? So I'll go for forward substitution. See, whatever is not required to remember, don't remember that, because it's not required. You can remember also, no problem. Your brain can store, you know, this world's, this universe data completely. Even supercomputers also cannot store. You can surpass even supercomputers' memory. So your brain, your memory capacity is really vast. So forward substitution. I uploaded one video. Did you watch that? If you have time, you watch. Water has memory. See, water also has memory. If you drink water, your memory will be improved. See, I uploaded that Sadhguru's. It's not my video. Jaggi was there. Sadhguru's Isha Foundation head. Okay, so he's saying that he gave that presentation in IIT Madras. It's part 5 of the presentation. I don't remember that properly. If you have time, please watch it. It's interesting, okay? So for, see, also devote your brain for spiritual purposes also, okay? They will enlighten you at times, no doubt in that. So forward substitution. So once, okay, now what I do now, please tell me what is my z1 here. So z1 is equal to 7.85. Now what is z2? You can simply tell me what is z2. See, I can I'll use this row multiplied by this column. So 0.
0.033 Z1
Okay,
plus Z2.
3 z1 plus z2 is equal to minus 19.3. This is second row, to pick second element. Okay, now you z1, you put this z1 here. Now you tell me what is z2. I don't have calci. I'm depending on you now.
Minus 21.89.
Are you sure? Are we not getting minus 19.6?
Minus 19.561, sir.
Yeah, I remember this answer. That's what I'm asking you. Sorry. Minus 19.5617. It doesn't matter. Sometimes in Overlook, what we do, we enter some wrong digits. So that may be the cause. So please, see, whenever you're doing computational method problems, uh, please give your time for calculations, because definitely in Overlook, we may do some mistakes. That's it. Otherwise, we all know things how to do. The only thing is Overlook will cause the problems. The problem is what you know, because already we understood that first of all, round off is only a big error in, without pivoting. And if you really miss your main digit, the entire things will change. And that's the problem. You should be very careful. Now, similarly, what must be Z3? I think Z3, I remember like 70.08. Please confirm this once. So Z3 is 70.0843. Correct me if I'm wrong. That's it. So Z1, Z2, Z3 you have. Z1, Z2, Z3. Just to verify and tell me.
Yes, sir, correct, sir.
Thank you. So Z3 is this. Now what I have. Finally, so we are done with this equation. Lz is equal to B. This is done. Now what else you have? It's not getting low. It's not shrinking. Where is my? It's not. I'm scrolling down the page, but it's getting stuck maybe. Okay, you just tell me Lz. Okay, Lz is equal to B is done. Then what we have? Ux equal to B, right? So Ux equal to Z. See, I have already we did this. Okay, Lz is equal to B, and from this we found out what is Z because I know L and B. Now what else we have? We have the main equation number 2, that is Ux is equal to Z. Now I know this Z, I know this U, then find out Mr. X. Now what is my U? I think I should have some Control C, Control V kind of thing. Do I have it anywhere? I'll just check me. At least in today's class, I must check it now. My system is stuck again, I think. It's not letting me. It's not letting me to navigate from one tab to other. Just OneNote, I think it's causing issue. What is this? This option. Just a minute, my system is hanging. Okay. Where is my page? Okay, I got it. I want, where can I copy? I haven't tried copying anything. Translate, row lines. What is this fellow? Okay, later I can check that now. It's not. I have stickers also. Just now, I think I saw it on the very first day, and then okay, it's taking time. Okay, seeing some love symbol. Okay, now no time to verify all this. So let me take my. Okay, I'll take my U. Okay, this is my U. 3 minus 1 like this. So U multiplied by x1, x2, x3 is equal to your Z. What Z we get here?
7.85.
Okay, 7.85
Minus 19.56.
5617 70.0843.
43.
All right. So simply now you exercise backward substitution. Okay. Okay, so you exercise that, and now x3 is equal to 70.0843 divided by 10.0120. So you must get almost the same answer
7.
like what you obtained. What did you get?
7.
Yeah, you will get approximately 7. That means you must get something like this, approximately. Yeah, something of this or stuff you will get. Similarly, x2 equal to, you must get like minus
Minus
2.5,
2.5.
and x1 is 3.
3,
Okay,
sir.
so finally you list out the stuff. Don't know why it's stuck in this. When I charge my laptop, this problem happens here every time. You know why? Because I'm charging at the same time I'm discharging the stuff. Because I'm using my laptop, right? I'm discharging, charging, discharging, charging, discharging. This is the problem. So therefore you should not use anything at the time of charging. Okay, you should not talk to your friend. While your mobile phone is in charging mode, you should never do that, because for branded pieces it's okay. If you take some other cheap pieces, they don't use proper filters or proper synthesizers. Definitely you will have these problems. Anyways, so so finally your x is 3, negative 2.5, and 7003. That's it. So this is the answer. And of course, see, your Stephen Chapra, your textbook, authored textbook, in the textbook, Kraut's decomposition is not mentioned. But I would like to say about that Kraut's decomposition. For your seniors, I gave that as a question, Kraut's decomposition. Maybe that may be a question, maybe in the end exam, who knows. So you have Kraut's decomposition, and Gauss-Jordan method will take, we require approximately some 50 minutes to complete that, and matrix inversion method. So with that, we can complete unit number 2. Then third unit is very small unit, so that will take more time. So we are inching towards the almost end of unit, not almost end. So I think we have covered some 70% or 80% of unit number 2. Why it's not responding? Let me open new page. I don't know why it's just okay. I want to change the how it's responding. Give me 1 minute. It's hanging out. So you can also do LU decomposition using pivoting, using partial pivoting. The multipliers you have to take appropriately. You have to make the pivot element as the largest element. Then again, A2 1 by A11, A3 1 by A11. So those things already you know. So LU decomposition is like this. And LU decomposition using partial pivoting is already you know. Okay. So you know how to do partial pivoting, right? You have to make the largest, you have to make the pivot element as the largest element in that particular column. So we know that how to do that, okay? So you just try in that line. Then let's go for Kraut's decomposition. Kraut's decomposition method. I mean, what I mean to say is this: LU decomposition or LU decomposition using Kraut's method. Otherwise, LU decomposition using Kraut's method. Anyways, you can do. Okay, anyways, you can construct this. Okay, now see, using Gauss elimination method, we made lower triangular. We took principal diagonal ones for the lower triangular matrix. In Kraut's decomposition, what you do, just ulta we do. That means in the upper triangular matrix. So we take all ones, all diagonal ones in the upper triangular matrix, and lower triangular matrix we need to find as usual. That means like this. So I have A is equal to L multiplied by U. Okay. Now what I do here, for example, let me take a 3 by 3 matrix for A. A 3 by 3 matrix for A. So I have A11, A12, A13, A21. Do you have offline or online exams? That means offline. Okay. So A21, A22, A23. So what did they say? Are they going to conduct? Offline means we don't have any MCQs, right? As usual. Okay, that's then derivations are important. If exams are as usual, derivations are also important. But in CM, 99% chances you will get only problems and little theory questions. For example, what is the advantage of open methods over bracketing methods? Those kind of questions they may ask, but very simple questions here. CM is really, really simple. That's it. So what is my L matrix here? I don't know. I don't know what is my L matrix. Then what do? Then take same thing, L11. I must take here L22 and L33. So this is L21, L31, L32. I know I'm considering by default a 3 by 3 matrix. Okay. So you have a 3 by 3 matrix again and multiplied by upper triangular matrix. Now we have a chance of taking all ones on the principal diagonal. My laptop is stuck again. I'm unable to access this pen. Okay, adjust with this color. It's not responding. 1, 1, and 1 again. Principal diagonal 1. So upper triangular matrix is again a 3 by 3 matrix here. And what about this one? This is U12, U13, and this is U23. That's it. Okay. Now, what I need to know here is I need to know complete L matrix. I mean, I have L11, L22, so on, L32, whatever. I should know everything. And coming to U matrix, for 3 by 3 U matrix, I should know what U12, U13, and U23. So how do we know that? Just multiply and get the answer. For example, I'll just take first row multiplied by first column. Then what do I get? L11 multiplied by 1 and equate this to A11. Okay, so finally what we found is L11 is equal to A11. That's it. So whatever is A11, that is the first element of L matrix. Straightforward. And how do I find this one? Now again you multiply this first row with the second column of U matrix. Then what you get? L11 multiplied by U12. That's it, right? Is equal to A12. Okay. So now what do I get? I can find out here U12. Okay. So U12 is equal to what? A12 by L11. And we know L11 is equal to A11. See, you have to also program this. You have to also develop a script for this in MATLAB. It's very simple. This is the We are doing the generalized form now. So this is A12 by A11. Agree? So finding out U12 is straightforward. That is what you're finding out. This one is, that means whatever I have, this divided by this. That's it. So see, L11 means what? The very first element of your A matrix. Okay. Now U12 is what? In your A matrix, you take the first row, second element by first element in the A matrix is U12. Similarly, how do I find U13? Again, same story, first row multiplied by third column of U matrix. So what I get now? L11, U13, that's it, right? Is equal to A13. So now what is my, it's again getting stuck, I'm sorry. It is not responding today properly again. U13 is equal to A13 by L11. See, A13 by L11 is equal to A11, that's it. So see, L11 means the very first element of A matrix. U12 means second element by first element of A matrix. U13 is what here? Third element by first element of A matrix. Yeah, so first row of L and first row of U matrix can be found